So the second in-class exercise, and I'm pointing you to wolframalpha.com, the particular website, to get the roots of the denominator. So we cut and paste this. Factorization is probably the easiest command to get all the roots. So actually, let's do this. I can't open those together, so I'll tell you what, let me.
Drag it all the way to the side of the screen. It'll snap. Keep going all the way to the curve. Yeah, keep going, keep going. There you go.
And this is what we have. So we're given that y prime bar equals s plus 1 over s fourth plus 3s cubed plus 2s e to the minus 7s. 2s. 2s? Yeah, I think it's 2. 2s. Okay? And to find y prime of t. So immediately we can write that the dictionary y prime of t is going to be 0 for t less than the delay, and delay function for t greater or equal. And how do I find that h of t minus 2? Well, I find h of t, and I replace t by t minus 2. How do I find h of t? H of t is the inverse of everything excluding the exponential. And of course, this is not in the dictionary, so we need to do partial fractions expansion. And what's the very first step for partial fractions expansion? Find the roots of the denominator so we can factor the denominator. Okay? So I'm showing you that. Now let's go to the Wolfram website. One issue we had last time is that it wasn't showing multiple roots. You use the factor command, it will give you multiple roots. You can use X or S. So let's change that to, okay, and let me use this. S to the fourth plus 3, I guess we don't have to put times, S cubed plus 2S. Oh, I didn't like it. Oh, a space. Okay, I guess it was a space. Plus 2S. So it's doing its calculation, and we want more digits for the complex roots, and click approximate forms and more digits, you see the real roots. Okay? So these are the roots of this. S equals 0 is obvious as factors, and we have a real root at minus 3.919 and a complex conjugate pair at 0.0979. So let's write on the board what the roots are. So keep writing this because that's what you're turning in when you're in class exercise, okay? So roots of the denominator. We have minus, well, let's write first the dominant ones. Which is the dominant? No, the 0 is not the dominant. The complex conjugate pair is the dominant. That has a positive real part. It's always the rightmost. So pole 1 and 2 is the complex conjugate pair, 0.0979. I guess 116.7%. Plus minus I times 0.785. Isn't that 00326? Let's see how many. 3, 6, 9, 10, 3, 6, 8. Okay, let's give a couple more. 32. Right. The next one is the 0, and the last one is the other real root, minus 3.1958233. So, we know our methods for doing this, and Adam, you did turn in your attempt with the complex conjugate roots. If it's a significant attempt on that, even if it's faulty, etc., give the 2-point bonus to anybody who returns significant attempt on the last part of the homework that I postponed. So, okay, up to here you're turning it in. Don't write separately parentheses because you're not turning in the next thing I'm discussing. Okay? So, I'll write on a different board. So, method 1, which is not the method you're going to do in, and I'm not going to do it fully because it would take probably the full 2 periods to do it. And I've done it correctly. I have done this correctly when I was stubbornly wanting the class to do it that way. And I decided that wasn't the best thing after all. So that's our standard partial fractions expansion. So we have C11. Yeah, I'll tell you what, since I'm just going to write the first few digits here. So f minus 0.0979 minus 0.785 I times S plus S minus 0.0979 plus 0.785 I times S minus 0 times S minus minus plus 3.195. So that's the standard partial fractions expansion. There is standard factorization, which was lead to partial fractions expansion. C11.
Wait, shouldn't that just be S plus 1 over
Did
here?
I mess up?
C11.
In the numerator should be.
The numerator
Oh.
should be S plus 1.
Yeah, sorry. Yeah, absolutely. Thank you. So C11 over S minus 0.0979 minus 0.785 I plus C21 over S minus 0.0979 plus 0.785 I plus C31 over S plus C41 over S plus 3.1958. Yes, ma'am.
How can you tell that none of these groups have multiplicity?
Each of them is a single root. It's a fourth of the polynomial, so the total number of roots is 4. So if I have 4 different roots, that's it.
Okay.
Also, I use the factor command that shows all the roots. It shows in a factor form, so you would see that. But basically, if you have a multiple root with a wolfram, you will see that factor squared, if it's a double. Okay, so we could use now the quick and easy method to get all of them. I'm just going to describe. So quick and easy, it gives me all the coefficients, but those guys are going to be complex. But they're going to be complex conjugate. Okay? So in a sense, you're saving some work because you only need to calculate C11, and for C21, just replace I by minus I. The other two, if you do the algebra, will come out to be real. With me? And then, so C21 will be complex conjugate of C11, C31, C41 will be here. And then you will find that the inverse of this, so that's the H bar. So H of t is going to be C11 e to the 0.0979 plus 0.785 I times t. Okay? See? The A is what? The A here is minus 0.099. Sorry, 0.099. Sorry, minus 0.099 minus 0.785. Remember that L inverse of 1 over S plus A is equal to e to the minus AT. And that holds whether the A is real or complex. The fact that they are complex doesn't change anything. Just makes it more messy, but in principle, it doesn't change anything. Everyone will be learning about real holds for complex. With me? Any questions? Juan okay? Felix okay? David okay? So, that's the, okay? So, A is minus that. So, minus A is this. And then I will get plus C12 into the complex conjugate of this. And then plus C31 inverse of 1 over S is 1. So plus, C21. C21 plus C31 plus C41 e to the minus 3.195 AT. And that's a perfectly correct answer, except it's not the answer you can plot. If you're calculating something real, I don't think you could proudly present that as what the concentration is doing. You need to convert it to a real. And to convert it to a real, what you would have to do is use that e to the I theta is cosine theta plus I sin theta. So this guy e to the 0.979 plus 0.785 I, all that times t, can be broken into the part that is real times the part that is imaginary. So this can be written as e to the 0.0979t times e to the 0.785 it. Or question?
Can you explain again what's your statement about C21 being a complex conjugate of C11?
Well, it means that whatever C21 was, you don't have to do any extra, whatever C11 is, you don't have to do extra work. You can just replace plus I with minus I to get C21. Complex conjugate means mirroring with respect to I. If you replace I by minus I, you get the complex conjugate. So that means you only have to do half the algebra.
Why did you put an I in front of the sign?
What do you mean?
That's the formula?
Yes.
Yeah, okay. Is this always what it is? Never mind.
You have learned that in calculus.
I don't remember.
Also, if you had taken COT with me, I went over it quite extensively.
Yeah, nope, I did not take CO2.
I guess the lad didn't go over it, right?
Nope.
Anyway, you should have learned it in calculus.
Maybe, I don't remember.
It's a very famous formula. I don't have the time to, I can prove it to you,
No, I was just-
but I'll be happy to, if you come to my office house, I'll be happy to derive it for you.
Oh, I'm fine. I got
Okay.
it, thanks.
And so this is then e to the 0.979 t times cosine